I'm just gonna run all of them, and then we can go through each one of them and talk about them. And length. And then max and max. Okay, cool. Right. So going through each one of them, we have the first one we start with my map one, right? And then we were allowed to I used the long way, the long currying function like we talked about on the slides. I wanted to kind of work with it and kind of get used to it a little bit more. We used the fold right function with three arguments, an anonymous function that an anonymous function that will append the x and the accumulator, which starts as an empty list. Here's a list. Uh, into it, so that it appends the x, the head, and then the accumulator, which is the list, as it is going through and applying every single one of um, the the process into each one of the transform list, right? For the next one, we have map two, and we have a recursion case, so we have to switch to a function. We couldn't use the long way. Again, we used the case of an empty list, right? We split the head and the tail. We used an anonymous function again, and we combine the results using f of x, not an anonymous function. We combine the results using the call to itself with the head, and then the rest of the tail, um, with map two being the recursive step, right? Until the decided list is empty. So we go through, we just decide the list until it is empty, right? And then we apply the results of the operator into the list. So for the third one, this one was pretty simple. Just kind of had to find a way to change it into characters, right? So yeah, we passed in a list of characters. We used my map one, and then we told it what to use, and the list to use. Again, it goes through, splits out all of them, passes in the function of whatever is going to be applied, and then um goes all the way through and applies that function, just like here. Would it work with either of them? We used map at first. By we, I mean me, but I used map at first to kind of check on it and make sure it worked, and then we switched over to our own implementation to make sure it was working fine. Then we did my length, which again we don't care about what every single one of the elements is. We wanted to use a way of counting every single number. Accumulator is zero. It starts at zero. Any list with size zero is going to be zero. Um, but we visit every single element, and we call the anonymous function, which has two values, x and accumulator, which is the current count. We only care about, again, the element itself, not the value of it. So again, we just increase until it reaches the end, right? Until fold to the right reaches the end. And then the last one is max. This one was one of the tougher ones. We have, again, fold to the left, three elements, right? And list is guaranteed to be non-empty, as stated in the problem. So we use the first element as our base, right? The current element and the accumulator is the largest value we've seen so far, right? And if x is greater than the accumulator, else x, then x, else accumulator, right? It checks whether the current element is larger, and if it is, x becomes the new accumulator. Otherwise, the old accumulator is kept, right? That if statement right here.